In this session, we are going to deal with data processing instructions. So what are the features of data processing instructions in ARM? Data processing instructions are used for performing arithmetic and logical operations except multiply operations, because for multiply you are having separate instructions. Next one is 3 address format. So 3 address format means in the instruction we are able to give 3 operands, right? Out of that, 2 operands will be of type source operands and the next operand will be used for storing the result, right? So 2 operands will be for source and 1 operand will be for the destination, right? And in these 2 source operands, first operand will be always a register. First operand should be always a register. Second operand can be a register or a shifted register or an immediate value. So first operand it will be always a register. Second operand can be a register or a shifted register or an immediate value, right? And the next operand will be the destination register. Then you can see there is something known as barrel shifter, right? So barrel shifter is used for performing multiple shifts using a single instruction, and this barrel shifter is available only for operand 2. Here you can see that two source operands are there, operand 1 and operand 2. To operand 2 only this barrel shifter can be applied, right? And this barrel shifter performs full 32-bit shift within an instruction cycle, but it can be applied only for the operand 2. So next we will see some examples for the arithmetic operation. So first we will start with the add operation. So there are 3 types of add instructions, right? So first one is add R0, R1, R2. What does it mean? So this is meant by 3 address formatting. That means 3 operands will be there. So in this add R0, R1, R2, R1 and R2 are the source operands, or the register R1 and R2 are used for specifying the source operands. And R0 is the register used for storing the result, or it is known as the destination register. So R0 is destination register, these two are the source registers. And what will be the operation? R0 will be equal to R1 plus R2. Content of R1 and R2 will be added together, result will be taken to R0. This is the first type of add. Next, in the next type, you can see that add R0, R1, hash 2. So what is the difference between first and second instruction? The second operand has been changed, right? So here second operand is an immediate value. What do you mean by immediate value or immediate data? That means in the instruction itself you are giving a data. That data is known as immediate data. So what will be the operation done here? R0 equal to R1 plus the second operand is nothing but immediate data, that is 2. So hash represents this is a data, right? So add R0, R1, R2 means R0 will be equal to R1 plus 2, right? So the data 2 is added with the content of R1 and the result will be stored to R0. Then the third type of add, here you can see the second operand is nothing but a shifted register, right? So add R0, R1, R1 LSL hash 1. LSL stands for logic shift left. Logic shift left, that is you are shifting the R1 register by 1 unit towards left, right? So what is the operation here? R0 equal to R1, that is the first operand, R1 plus R1 left shifted by 1 unit, right? R0 equal to R1 plus R1 left shifted by 1 unit, right? So these are the 3 different types of add. So that is what I have told in the features. There are two source operands. First operand will be always a register. Second operand can be a register or an immediate value or a shifted register. Second operand can be a register, immediate value or a shifted register. So that is what is shown here. Right. So second operand can be a register. So in the first case it is a register. In the second case it is an immediate data. In the third case it is a shifted register. Right. So in the data processing instruction, the second operand can be a register like this, or it can be an immediate data like this, or it can be a shifted register like this. But you need to keep in mind, always the first operand should be a register, right? And the destination destination value also should be a register, right? These two should be a register, but the second operand can be a register or an immediate value or a shifted register. Then we will see one by one. So this is the first instruction, add R0, R1, R2. So this is the operation done. R0 equal to R1 plus R2. How it is done? Let us take one value. Say R1 is having a data 0001. R2 is having another data 0022. So this 0x shows that these are hexadecimal values. So in R0 what will be there? R1 and R2 will be added together. Result will be stored in R0. Right? So when you are adding R1 and R2, you will get 3. The binary representation of the same example will be like this. So 31 zeros and 1, that is represented by 0001. You are adding with 0002. What do you mean by 02? 0010 in binary. 2 means 0010. When you are adding these two together, what you will get? 1 plus 0 you will get 1. 0 plus 1 you will get 1. So 0011 means it is actually 3. Right. Then we will see another example. So here you are taking R1 as all F's. That means all 32 bits will be ones. You can see here. To that you are adding R2. R2 is having 1. So FFFF all F's plus 1, what will be getting? Your result will be 0 with a carry 1. Right. That means FFFF is the maximum 32-bit value which can be accommodated. When you are adding 1 to it, what will happen? Carry will be generated and the result will be all zeros. Right. So how will you identify a carry is generated or not? By using something known as carry flag. Right. And where is this carry flag available? In the CPSR. Right. So here, since carry is generated, carry flag will be set as 1. Similarly, one more flag will be set. What is that flag? That is known as a 0 flag. Why? Because when you are performing this addition, you got the result as 0. So whenever an arithmetic or logical instruction is generating 0 result, 0 flag will be set as 1. So where are these two flags available? In the CPSR. So this is a CPSR. So this is a carry flag, this is a 0 flag. So when you are performing this operation, both the carry and 0 flag will be set. Right. So what is the instruction written for performing this addition? Add R0, R1, R2. So when you are performing R0, add R0, R1, R2, this addition will be performed. Result will be generated. In addition to that, these two flags will be set, or these flags will be updated. Yes or no? Any doubts whether this statement is right? When I am writing this, these two flags will be set. Yes or no? No. Right. This instruction is wrong. Right. When you are writing this instruction, flags will not be reflected. Only you will be getting the result. When you are writing this instruction, result only will be generated. Flags will not be reflected. So how will you update the flag? For that you need to write this instruction. What is the difference between the first instruction and this one? There is one additional S in this instruction. So if you are writing this S prefix to this instruction, then only the flags will be updated. So this S stands for status flag updation. So if S is added with a whatever data processing instruction you are writing, whatever may be the data processing instruction you are using, if S is added with that, then only the flags will be updated. You should keep in mind. Otherwise, only result will be generated, flags will not be reflected. So whenever flags need to be updated based on any arithmetic or logical instruction, you need to add this S bit to the instruction. Right, whatever it may be, whatever data processing instruction it may be. So we'll take another example. So same instruction you are using with the S, so flags will be reflected. So here I am making, here my R1 is 7FFF, to that I am adding 1. So when I am adding 1 to 7FFF, what will I get? I am adding, this is 7FFF, to that I am adding 1. Right, so what will I get? I will be getting 8000. Right, I will be getting 8000. So here in R1 you can see that first or the MSB most bit is 0. Here in the result MSB most bit is 1. Right. So what is this value? 7FFF means, what is this value? What is the specialty of this value? MSB most bit is 0. So what does this MSB most bit represent? It represents the sign bit. So MSB bit of a binary number represents the sign bit. If it is 0, that means your number is positive. So 7FFF means in decimal the number is this. When you are adding 1 to it, what will happen? You will get 8FFF. But what is this? 8000. So what is this number? What is the sign of this number? MSB bit has been changed to 1. That means sign has been changed to negative. Right. So here what has happened? 7FF means this is the maximum possible positive number you can have. Right. So in order to represent it as positive number, the MSB most bit will be 0. But when you are adding 1 to this maximum possible positive number, what will happen? The result, in the result, your MSB most bit will be 1. That means the positive number has overflown to a negative number by making the MSB bit 1. So how will you identify this overflow? So this overflow has taken place. Why it has taken place? You have performed a signed addition. So while signed addition is taking place and an overflow has occurred, what will happen? How will you identify that? Overflow flag will be set. What is overflow flag? V flag. So while you are performing signed addition and overflow has occurred, overflow flag will be set. But when you are performing unsigned addition and carry has been generated, what will happen? Carry flag will be set. Carry flag is associated with the unsigned addition and overflow flag is associated with the signed addition. Right. So in addition to this overflow flag being set, anything else will be set? Negative flag also will be set. Why? Because your result is a negative number. So whenever an arithmetic or logical operation is generating a negative result, negative flag will be set. So where are these two flags available? In the CPSR. So whenever you are performing signed addition and overflow has been generated, overflow flag will be set. So next we will see the second type of add. So here my second operand is an immediate value. What is my immediate value? 2. Right. So let us take my R1 is having 0001 as data. To this R1 you are going to add the immediate data 2. So when you are adding 1 plus 2 in R0 you will get 3. So this is a binary representation. When you are adding content of R1, that is 0001 plus 2, you will get 3. Let us take another example. Here instead of giving the immediate data like this, I have added one more thing known as AND. I have written it like this, AND F. So what does this AND represents? AND shows that the next data is a hexadecimal data. But here I have written only #2, that means 2 will be taken as a decimal data. But if we are writing and if we are writing F, what does it mean? F will be taken as a hexadecimal number. So here what will happen? Content of R1 will be added with 0000F and result will be taken to R0. So let us take content of R1 is 0001. To that you are adding 000F. What will you get? You will get 10, right? 0001 plus 1111. What will you get? 1 plus 1 will be 0 with the carry 1. Again 0 with the carry 1. 0 with the carry 1. Right. So the result will be 000010. Then we will see the third type of add. So here the second operand is a shifted register. So what will be the operation done here? R0 equal to R1 plus R1 left shifted by 1. Right. More details of the shifting we will see in the forthcoming slides. So now we understand that LSL stands for logic shift left. And #1 shows how many times you need to shift left. Right. So here you need to shift only once. Right. So what is the operation done here? R0 equal to R1 plus R1 left shifted by 1. Right. We'll see one example. Let us take R1 is having this data 0001. To that you are adding the same R1 left shifted by 1. Right. That is 1. When you are left shifting by 1, what you will get? For more understanding, we will take the binary data. So let us take R1 is this 0001. To that you are adding R1 left shifted by 1. So when you are left shifting this R1 by 1, what will happen? So previously it was 0001. When you are left shifting by 1, what you will get? This 1 will move to the next position, next MSB position, or the first bit position. So what you will get? When you are shifting 0001 by 1 unit towards left, you will get 0010. So what is this 0010? It is nothing but 2. So when you are adding 1 plus 2, you will get 3. If you are left shifting this 2 again by 1 towards left, what you will get? This 1 will come here. That means you will be getting 4. That means whenever you are left shifting a number towards left by 1 unit, you are actually multiplying it by 2. Right. So when you are left shifting 1 by 2, 1 by 1 unit you will get 2. One more unit if you are left shifting you will get 4. When you are shifting one more time you will get 8, like that. So whenever you are shifting a number towards left by 1 unit, you are actually multiplying by 2. So if you are left shifting a number by 2 times towards left, what will happen? That number will be multiplied by 2 raised to number of times shift. So if you are left shifting by 2, what will be the actual number? That number into 2 raised to 2. Right. If you are left shifting a number by 3 towards left, you are multiplying that number into 2 raised to 3. That number into 2 raised to 3. So 2 raised to how many times you are left shifting towards left. How many times you are shifting towards left. That value. Right. When you are performing this, you will get the actual number. Right. So this is how the left shifted register operation is performing. So here what is happening? R0 equal to R1 plus R1 left shifted by 1. Right. That means R1 left shifted by 1. What does it mean? It is actually 2 into R1. Right. So how will you rephrase it? R1 plus 2 into R1. How will you again modify it? So you are adding R1 plus 2 into R1. What is the result? You will get actually 3 into R1. Right. So by writing a single instruction like this, you are actually multiplying R1 by 3. How you are multiplying R1 by 3? You are adding R1. To that you are adding R1 left shifted by 1. When you are left shifting R1 by 1, you are actually multiplying R1 by 2. Right. So 2 times multiplied R1 plus R1. So total you will be getting 3 R1. So by writing a single instruction, you are multiplying R1 by 3. So next we will go on for the next instruction, that is known as ADC. ADC stands for add with carry. Previously it was ADD, add. Here ADC means add with carry. So here ADC R0, R1, R2, what does it mean? R0 equal to R1 plus R2 plus C. C is carry bit in CPSR. So let us take R1 is having 1, R2 is having 2, and carry bit in CPSR is set. It is 1. So what will happen if you are using ADC? Content of R1, that is 1, plus content of R2, that is 2, plus content of carry, that is 1. So 1 plus 2 plus 1, you will get 4. So this is a binary representation. You are adding 0, 0, 0, 1 plus 0, 0, 1, 0 means it is 2. That is 1 plus 2 plus 1. You will get 4. So here only difference is that you are adding carry also along with the R1 and R2. And the whole result will be taken to R0. Next one is sub instruction. So sub R0, R1, R2 means R0 equal to R1 minus R2. You are subtracting R2 from R1. So R1 minus R2. Let us take your R1 is 3, R2 is 2. When you are subtracting 3 minus 2, you will get 1. So this is a binary representation. 3 minus 2 will get 1. We will take the next example. You need to subtract 2 minus 3. So what will I do? I can rewrite it like this: R0, R2 minus R1. Instead of R1 minus R2, I am writing R2 minus R1. So what will be the operation? R0 equal to R2 minus R1. Same operation can be done with the help of another instruction known as RSB, reverse subtract. So you should keep in mind, reverse subtract, this same format you should use: R0, R1, R2. So reverse subtract means the operation will be second operand minus first operand. If you are using sub instruction, the operation will be first operand minus second operand, R1 minus R2. First operand minus second operand. In RSB means it is reverse subtract. So the subtraction will be in the reverse manner. R2 minus R1. That is second operand minus first operand. Here it is first operand minus second operand. Right? So opposite of this will be done here. Second operand will be subtracted with R1. So R0 equal to R2 minus R1. Right? So instead of writing sub R0, R2, R1, you can do the same operation by using reverse subtract. Reverse subtract R0, R1, R2. So what does it mean? R0 equal to R2 minus R1. Right? So both the instructions are the same. So whenever you want to reverse the order of subtraction, you can use reverse subtraction. So let us take one example. So here let us take R2 is 2, R1 is 3. So you are subtracting R2 minus R1. The same thing, R2 minus R1. So what will happen? 2 minus 3. That means what will happen? 2 minus 3, you will be getting negative 1 as the result. But here you are getting FFFF, right? And which flag will be set here? Negative flag will be set. This is one of the flag. One more flag will be set that we will see in the next slide. But even though it is negative, you are getting something different. When you are subtracting 2 minus 3, you should get negative 1. Right? But here you are getting other number, all FFFs. Right? So why it is coming like that? So in ARM, negative number will be represented in a 2's complement form. In ARM, negative number will be represented in its 2's complement form. So this is actually 2's complement of negative 1. So how will you get back the actual number, or how will you get the positive number from a 2's complement? Right, if you want to get it as 1, 2 minus 3, it will be 1. So how will you get back the number from this 2's complement number? You should take 2's complement of this 2's complement. So 2's complement of a 2's complement number, you will get back the actual number. We'll see how it is coming. So all FFF means in binary it is like this. In binary it is like this, right? How will you take the 2's complement of this 2's complement? How will you take it? How will you take a 2's complement? Find the 1's complement. So 1's complement of this number, what will be? How will you get that? Replace all these ones with 0. That is known as a 1's complement. So when you are interchanging 1's with 0, you will be getting 1's complement. Then how will you get 2's complement? This is 1's complement. How will you get 2's complement? Plus 1. So this 1's complement plus 1, you will get the 2's complement. When you are adding 1 to this, what you will get? 0, 0, 0, 0, 1. Right. So this is how you are getting back your actual number from a 2's complement form. Right. So this was actually a negative number. In order to, so negative number will be represented in the 2's complement form. For getting the actual number from this 2's complement form or from this negative represented number, how will you do? You can take the 2's complement of the number. So when you are performing 2's complement of FFFF, you will get back 1. Right. So if you want to get the actual result of this operation, you need to take the 2's complement of this number. Right. So in ARM, the negative number will be represented in its 2's complement form. So if you want to get the actual value of that number, or if you want to get the actual number from that, you need to take the 2's complement of this number itself. So let us take the same example, right? So here you have seen that negative flag will be set, but in addition to this negative flag, one more flag will be set. What is that? Carry flag will be set. Why this carry flag is set? So I have already told that when you are subtracting 2 minus 3, you will be getting negative 1. So when you are subtracting a bigger number from a smaller number, borrow will be generated. Right. So how will you identify whether borrow is generated? There is no separate bit for representing borrow. So borrow is represented by using carry bit itself. How it is done? So while you are performing addition, if carry is generated, carry flag will be set. And while you are performing addition, carry is not generated, then carry flag will be clear or C will be equal to 0. But when you are performing subtraction, C equal to 0 means borrow is generated. C equal to 1 means there is no borrow. Right? So while performing addition and subtraction, how will you identify? Carry equal to 0 in addition means it represents there is no carry. But the same thing carry equal to 0 while performing subtraction means there is borrow. So borrow and carry, it is actually represented in its complement form. So borrow can be written as not of C. So whenever you are performing subtraction, borrow will be equal to not of C. What does it mean? If carry equal to 0, carry bit equal to 0 means what will be borrow? Not of carry. So when carry equal to 0, borrow will be not of carry, that is borrow will be 1. Right. So when carry equal to 0, borrow will be 1. When carry equal to 1, borrow will be 0. There is no borrow. So how will you represent? Borrow can be represented as not of C. Right. Borrow can be represented as not of C. So that you can see here when I'm writing SBC. So SBC stands for subtract with carry. So in carry I told, in subtraction I told there is no carry, it is only borrow. But in the instruction it is specified like this, subtract with carry. So how it is done? R0 equal to R1 minus R2 minus B. Right. Right. So there was an instruction known as ADC. ADC means add with the carry. So what is the operation? R0 equal to R1 plus R2 plus C. But here it is SBC. SBC stands for subtract with the carry. So carry also should be subtracted from the subtracted result. So R0 equal to R1 minus R2 minus B. So how will you rewrite this equation? How will you rewrite this? It is same as R0 equal to R1 minus R2 minus naught of C. Why? Because borrow is nothing but naught of C. Right. So let us take one example. My R1 is 003, R2 is 1, carry is 0. Carry 0 means borrow is there. So if carry 0 means what will be borrow? Naught of C. Borrow will be naught of C. Naught of C is what? 1. So here what will be the operation? R1 minus R2 minus C, or minus naught of C, minus borrow. R1 minus R2 minus borrow. What does it mean? 3 minus 1 minus 1. So 3 minus 2, that will be 1. So this is a binary representation. 3 minus 1, again minus 1, because this is a borrow. So final result will be 1. So this is how you are performing subtract with the carry. So borrow is nothing but naught of C. Right. Next one is RSC. What does the RSC means? RSC stands for, what is RSC? RSC stands for reverse subtract with the carry. Previously you have done R1 minus R2 minus C. Here it is the reverse of that. The subtraction will be reversed. Right. We have seen subtract and RSB. Here it is SBC and RSC. RSC means the order of subtraction has been changed. Right. You are subtracting R2 minus R1. Right. In SBC how it was? R1 minus R2. First operand subtracted with the second. R1 minus R2. But in RSC it is the opposite. Second operand minus first operand. That is R2 minus R1. Previously it was R1 minus R2. Here it is R2 minus R1. Then since it is reverse subtract with the carry, minus borrow is also there. So borrow is nothing but naught of C. We'll take an example. R2 equal to 3, R1 equal to 1, borrow equal to 1. Right. So how will you do that? R2 minus R1 minus borrow. So 3 minus 1 minus 1, it will be 1. Right. So only difference between RSC and SBC is that the order of the source operands will be reversed. Here it is first operand minus second operand. In RSC, it is second operand minus first operand.